Now we'll look at Sharpe's single index. This is used to construct an optimal portfolio. The problem: Mr. Mohan wants to invest rupees 10 lakh in stock market. The treasury bill return is 5% and the market variance is 10. Following information gives details of expected return, beta and variance of various securities. Construct the optimal portfolio. So the information is given for the different securities, their returns and their beta factors and the variance. Here beta factor is known as systematic risk because it is a market risk. Variance is known as unsystematic risk because it is the risk related to the stock. The solution. What are the information given? Treasury bill return, that is nothing but your risk free return, RF, that is 5%. Market variance, that is 10. Total amount investment 10 lakhs. Now, step 1, ranking of securities. We need to use this formula to rank the securities. RI minus RF divided by beta. We have to rank from highest to lowest. We write the information given in the problem, the stock names and their respective returns, their respective beta values. Now apply the formula Ri minus Rf. Rf is given in the problem as 5%. So 15 minus 5, 10, 12 minus 5, 7, 11 minus 5, 6, and similarly you get all these values. Now Ri minus Rf divided by beta. Beta is also given in the problem. So 10 divided by 1, 7 divided by 1.5, 6 divided by 2.3 divided by 0.8, 4 divided by 1, 9 divided by 1.5 will give all these values. Now looking at these values, the highest number is 10, that belongs to security A. That will be ranked as 1. The next highest is F and that will be ranked as 2. The next highest is B, that will be ranked as 3. And the next highest is E, which will be ranked 4th. And the next highest is D, which will be ranked 5th. And the last highest is C, that will be ranked as 6th. Next step, step 2, we need to calculate the cutoff. Rearrange the securities according to their ranks. Then calculate the cutoff using this formula. C is equal to market variance summation of Ri minus Rf into beta divided by variance of the stock 1 plus market variance into summation of beta square divided by variance. Now we need to calculate all the values required for this formula. Rewrite, the main thing here is rewrite the securities according to their ranks. So rearrange them. First rank is A, second is F, third is B, fourth is E, fifth is D, and the last is C. Write their respective returns. We have for A as 15, F we have 14, for B we have 12, E we have 9, and D we have 8, and C we have 11. Similarly, write their respective betas. Beta for F, B, E, D, and C. Now, the variance is already given in the problem. Similarly, write the variance of A, F, B, E, D, C. So, be careful while writing the respective values. You should write the values for those securities. We will first calculate the value Ri minus Rf divided by variance into beta. So substitute for each of the securities the values and calculate it. Ri will be 15, Rf is 5, beta is 1, variance is 30. So when I substitute these values, I get 0.333. Similarly, for F, Ri is 14, Rf is 5, beta is 1.5, variance is 1. When I substitute and calculate, I get 1.350. Similarly, you calculate this value for all the stocks. We get these values. Now, this is the important point. summation of Ri minus Rf divided by variance and beta. So we have got these values. Now we have to find the summation. Here it is cumulative summation. Please note this is cumulative summation, that is 0.333. Then the next value is got by adding 0.33 plus 1.350. So we get 1.683. The next value is got by adding 1.683 plus 0.523. So 1.683 plus 0.525, we get 2.208. The next value is got by adding 2.208 plus zero point 0.2, we get 2.408. The next value we get by adding 2.408 plus zero point 0.240, that is 2.648. The last value we get by adding 2.648 plus 0.3, 0.3. Now, we'll find the value of beta square by variance. Beta square is 1. 1 square divided by variance is 30. We get 0.033. Similarly, beta square 1.5 whole square divided by 10, we get 0.225. So, substitute the respective values for each stock and find the value of beta square divided by variance. Now, here also, summation of beta square divided by variance. Here also it is cumulative summation, that is 0.033 will be the first value. The next value is 0.033 plus 0.225. We get 0.258. The next value is 0.0258 plus 0.113, that is 0.258 plus 0.113. The next value is 0.2. How do we get the next value? 0.371 plus 0.050, that is 0.421. Then the next value is got by adding 0.421, 0.064, that is 0.485. Similarly, 0.428, 0.485 plus 0.1 will give us 0.585. Now coming to the cutoff. How do we calculate the cutoff? So the cutoff value we have C is equal to the given formula. We have calculated this value and we have to multiply beta to this, and then we have calculated the beta square by variance. So now substitute all these values for each of the stock. For A, cutoff of A will be, market variance remains the same, 10 into 0.33 and divided by 1 plus 10, market variance is 10, 10 into, we have calculated this value 0.0333. So we get the value as 2.504. Similarly for F, cutoff for F, market variance into the value that we have already calculated in the previous table, 1.683 divided by 1 plus 10 into 0.58. So you substitute the values for each of the stock and we get the cutoff values as follows. Now if you observe, 2.504 is increasing to 4.701, but after that the value has decreased to 4.688 and it has been decreasing. So we take the cutoff point as the point till where the values are increasing. So the till where the values are increasing, and when the values start decreasing, we mark stop till there. So this is your cutoff point. So if you write the cutoff point now in this table that we saw previously, writing all the values, we see that this is your cutoff point because values start decreasing after this. So we will select only those securities which are above the cutoff point. That is, only A and F are above the cutoff point. So only these two securities will be selected to construct a portfolio. Now that we have selected A and F for the portfolio construction, now let us look at the step 3. What is step 3? Calculate the proportion of investment to be made using the Z factor. How do we get the Z factor? Z factor is beta square divided by variance of the stock, Ri minus Rf divided by beta minus C. So we have already calculated these values. So this we have already calculated, and this part also we have already calculated. Only thing is we need to substitute the cutoff point that we have. Optimal portfolio consists of security A and F when proportion, where proportion will be, what will be the proportion of A? So Z factor of A will be the value of this which we had calculated 0.33, and then the value of this which we have already calculated, that is 10 minus what is the cutoff value according to our calculation, 4.071. Then we substitute and calculate, we get 0.175. The same way, Z factor for F, the stock F, that is 0.225, this value, and this value according to the calculations, 6 minus 4.701, which is the cutoff, the this value, and so the answer will be 0.292. So the proportion of A is 0.17, proportion of F stock is 0.292. The total proportion is 0.175 plus 0.292. So the proportion of security A will be 0.175 divided by the total proportion into what is the amount available for investment, 10 lakhs. So totally we get 3,74,700. The proportion of security F, how much should be invested in security F? For that, we take the proportion of F divided by the total proportion into 10 lakh. So that is rupees 6,25,300. So the investor who has 10 lakh rupees for investment will invest on security A and security F. And how much will he invest? In security A, he will invest 3,74,700, and in security F, he will select 6,25,300.